Dan.
Press
Yeah. We all set up?
yeah.
My name is John Kosinski,
I'm Danny Marino.
I'm Michael Wolf.
and our group is Data and Technology. So I want to start with just going over who each of us are, what our different roles were in the group. And I want to start my position, or I guess team role, was coordinator. I was responsible to make sure we were all on task 24/7. We knew what we were all working on and when. We were coordinating our events together, and
My role was the initiator. I started discussions, led discussions in different ways, and I listened to ideas and branched off of them.
As an evaluator, I assessed team progress and made sure deadlines were met. I also validated our task completion and promoted open communication between each other.
So just an introduction to our presentation, basically what we've been doing all year. EDD is a very unique class. There's no set schedule to what you're supposed to do anyway. All groups work at their own pace. Some are faster than others. Others might be done with one of the elements super fast, while others might take a little longer on those. Which is why when we get the opportunity to do this, it's such a fun and unique experience that it's something new that we've never been to before. And it really gives us a taste of the new world that we're going to as engineers.
So here's a statistic of the dangers of sun glare while driving. So 9,000 accidents occur annually due to sun glare, and the risk of life-threatening accident is 16% higher in bright sunlight than in normal weather conditions. So this is our problem statement. Our problem statement is an issue that needs to be addressed and solved. We center our solution around this problem statement. So every day, millions of people rely on vehicles as transportation, whether it is to get to work, school, or any other location. However, getting to these places during unsafe conditions such as poor weather, icy roads, sun glare, and other factors creates many problems on the road. Many recent statistics suggest that road crashes are the leading cause of death in the U.S., with over 38,000 deaths a year. And weather-related crashes are about 21%. The unsafe conditions reduce drivers' decision-making, ability to stay in control, which all lead to a great risk of transportation.
So for our target demographics, we asked our class, family, and friends the question, have natural factors like sun glare impair your ability to drive? And we found that 89% of these 18 responses said yes, and one said no, and we also had another. Following that poll, we got 26 responses on the question, on a scale of 1 to 10, how much did these affect you? And we had 70% of people voting 5 or above, and we also had 15% of the 26 people voting they were affected 2 to 3 minutes, and another 15% affected from 4 to 5 minutes.
So in our research looking for solutions to some of these problems that we found, we researched existing patents that were sort of aimed or targeting some of the issues we ran into. Mine was, I primarily focused on different sun glare and things that impair your eyes while you drive. One of the designs I found was this device you could install whether inside your house, inside your car, and you could flip it around sort of like a crescent moon that would cover a wide area, ideally limiting the amount of sunlight that was going into either your car or that room. Some of the problems we found with this invention or patent was that it was not easy to install or remove. Once you installed it, it was set there, and it was a big effort to take it out, which really isn't what we were aiming for. We were looking for something simplistic that the everyday person could do with really no issues.
So for my patent, this is one of the designs that helped shape our final design. But we didn't exactly copy this because it wouldn't be ethical to. But we decided to innovate it and add a tint and make it less bulky because there's a lot of mechanical parts going on here. And over time, it's not going to last long. So we decided to go for a more simple product and add tint and make less mechanical parts.
My pen was also very similar to our final design. Instead, this is an object for rear mirrors and side mirrors that is placed that prevents headlight glare from shining in the eyes, either blinding or distracting the drivers. So this is my early idea that we came up before we chose our final design. It's a side window wiper to wipe off any snow, rain, ice, condensation. The reason we didn't use this is because it's too complicated for the time we have in class. It's also too expensive for our $100 budget, and it wasn't very well thought out.
Going off of that, my idea was similar, but I mainly targeted the front windshield. One of our, like you said earlier, one of our additional ideas before focusing really on sun glare was removing snow and ice and different like winter weather conditions from a vehicle. Some of the issues we ran into this was the limited testing phase. If we decided to go with this design, by the time we were actually done developing it and creating it, it would most likely already be spring into early summer. So we would really have no actual testing data to get. Another issue we ran into was it was too complicated for us at the time. We didn't have the expertise nor ability to correctly and thoroughly execute this design.
So this is my idea, and this is what ended up becoming our final product. But the little innovation because of what happened with 3D printing, but John will say about that in a second. We decided to do this because of its feasibility with our time frame. Like John just said, the seasons are changing, and we wouldn't be able to test the other two products because they need snow and ice to test. So by doing this, we'll have no complicated test procedures and get more valuable data. So our decision matrix, we had 5 designs, and 3 of them being the last 3 we just saw. We decided to use cost, complexity, the ease to implement, development time, price, and necessity, and we rated each product on a scale of 1 through 10, 1 being the best, 10 being the worst. We had John's design, which was the device to clear up snow and ice from the front windshield. Michael's, which wipes the side windows with snow and ice, and mine ended up becoming the final design, and it ended up with 76 points, which was least out of all. So with our material plan, the first material that we used and bought was the acrylic sheet, which is the tint for the product. It was around $22, and we got 2 big pieces of tint, and we got it from Amazon. Our next material was the 3D print filament, which costed nothing because we were able to print it non-stop without any cost, which is the majority of what the product is. The frame, the clip, and the rods connecting both. We also bought super glue for $8, which binds the plastic together and keeps the rods intact.
Some tools and equipment we used was a 3D printer, which we created most of it out of. We created a frame piece, a clip, and a clip rod, which attaches the spring or the clip and the frame together. Then we took apart a clip, figured out how it worked. Then we put the spring from the other clip into our clip. And then we used a laser cutter to cut the tinted sheet to the size that we like so that it'll fit in the frame. And lastly, we use a drill press to cut holes into the frame and the clip so that the rods will fit in the flesh.
One of the statistics further proving our idea was worth it was that approximately 64% of adults in the United States wear eyeglasses, and it could be expensive to buy prescription sunglasses or the ones that transition, which is around, I think, $200. But the total available market is around 225.81 million people for this product, so that's one of the reasons why we thought it was worth it to pursue.
Some of the design specifications I wanted to go over that we gave ourselves for design were that we wanted to decrease driver distractions without reducing visibility. Because if you can decrease distractions but obstruct your vision, it really serves no benefit. So we need to be doing both of those at the same time. We want this product to cost the consumer either $10 to $50 because of some of the points we talked about earlier with transitional prescription lenses, which can go up to $200. We want something economical that solves the issue that maybe if they can't afford that, this will help them instead. So it's not really a viable idea to have it cost the same. And we need it to be compact and appealing for all cars. The design could work perfectly, just as intended, but if it doesn't look good, no one's going to want it installed. Like, yeah. And then it must be legal and not contradict any pre-existing laws. So some of the things we researched were how much light actually needs to go through inside your car before becoming illegal. We discovered that in the state of Illinois, it's around 5 to 10%. Any less than that would be illegal, and we really did want to avoid a lawsuit. Some of the other stuff alongside that, we wanted to make sure our product at all times wouldn't interfere with the driver's ability, because if it did and that driver perhaps got in a crash or got arrested for whatever reason, we'd be held liable and that would come back to us, which we could either get sued, put in jail, or worse. Some of the other stuff we wanted to talk about was we didn't want it any bigger than 10 inches in height and 18 in width. This is connecting with our point one, that we don't want it to obstruct any vision or be too bulky to the point where the driver would be distracted by this item. We also want it to be durable and long-lasting. We tried to use as little moving parts as possible because anything moving will eventually fail. And if it costs a certain amount of money, but it keeps breaking continuously, our users are going to be racking up a bill over and over again that eventually will just become unsustainable. A few more design specifications that we wanted to talk about were it needs to be easy for the user to implement. We don't want the driver, user, whatever, to be struggling with this, so to the point where they can't use it or they're just putting in a lot of time and effort. We really don't want them to. We want it to be simple enough where it takes 30 seconds from getting in your car to install it. So after that, they can just deal with it. And we wanted the device to be able to rotate up and down. So if you're driving for a road trip, long period of time where you can't really pull over to remove it, we want to be able to just flip it out of the way so it doesn't really bother you anymore and you can continue driving without damage. Some of the EDD specifications were we needed to stay within a $100 budget. We did this well. We only spent around $25 or $30 for our budget, which means we're very cost effective, efficient. We really didn't spend money on anything we didn't need. And we also needed to be able to complete it before today, which we obviously did. So when we decided on picking our final design, that was one of the main things we tried focusing on.
One of our experts was Marino Guzman, who is an electrical engineer. He helped us incorporate engineering principles into our design, such as ensuring efficiency and safety. He evaluated our testing processes, and we asked them to rate it on an A through F scale. And he gave us an A-, and he gave us some feedback and told us we should do it earlier in the day because we can't be racing the sunset. Also, to get a more effective poll sample, and adding more people to our poll so we can get more valuable data.
So some of the CAD modeling we did for this, we started working on our clip design that we could use to connect to any pre-existing sun visor. And then from that point on, we decided to work on designing a frame where it was thin, very, just not in the way, very minimalist. And we would also be able to easily slide in and then secure a tinting acrylic piece that would be very easy to deal with, manage, and didn't require any complex installation. We then designed 2 thin circular rods. These would be used to actually connect the clip to the frame itself and also complete the assembly of the clip. I have a few pictures of our design process. This is probably one of the hardest parts that we ever went through. We had a lot of issues when we first started experimenting. I can say we probably went through 6 or 7 designs with the clip before we finally decided on our main one. We had a lot of issues with 3D printers themselves. It was just a lot of bad luck combined with questionable design choices that made us take a little longer than we would have liked. But we eventually decided on a design that we liked. We took some inspiration from existing chip clips and such that already exist because we figured we don't need to make something more complicated than it needs to be because there's really no point. And this is some more pictures of the frame we designed. We had to design the frame into 2 separate pieces to print out because of how big it was. Eventually we went to 4 when we had to expand it. But the idea was we would print it separately, connect it, and it would fit well, and it did. So here's some pictures of the tint. Unfortunately, we had to have it in a protective film most of the time, so it wouldn't get scratched, injured, or dirtied up before. But basically, we purchased 2 pieces of this acrylic tint off of Amazon. One so we could experiment with the first one before deciding on our final design. This worked very well. We discovered that the tint that we use is actually very effective. It would take any like pulsating light sources, just make it pretty solid, so it's not like bulging out. Like the sun, it like you know what I'm talking about. Like it bulges out like that, and this really reduces that, so it makes it less inconvenient. So here is our assembly of our final design. You can see that there's the clip on top, which will then connect to the frame using a pre-existing rod, and it would look like that. So here's pictures of the final realized solution. We did some in-field testing, placing it different places in the sun visor, and we found it was most effective to clip it into the back, where it would be at least 1.5 feet away from the user, so it wouldn't interfere with their ability whatsoever, while also covering an ample vision field. Here we have a testing video. Basically, what we did was we took an app that would measure the amount of brightness that's going through your phone front camera. This was a pretty cloudy day when we did it, so we didn't have as high as a number as we would have liked. But we started around 1100 lux. Lux is a unit used to measure brightness. So basically, it is lumens per meter squared. That basically talks about how much light is at that certain point. Started with around 11,000 going to around 800. So we saw a very big decrease that we liked. And here is some statistics that actually backed it up. So first we did testing in a driver's seat on a somewhat cloudy day. We had around 26,000 before, and we landed around 1,200 afterwards. We were very proud of this result. It proved that something we were looking for actually worked, and we had some statistics to back it up. We did some stuff on a severe overcast and darker scenarios to see maybe if it was too dark, would it interfere with your ability to drive? We found that wasn't necessarily the case. Although it does brighten your vision, it does not to the point where it would be difficult to drive. There are some issues where at night, if you have it on, it can get very dark. That's why we suggest moving it up into the off position before. And then on a very sunny day when the sun was shining the brightest, we had around 45,000 before going down to 6,400, sorry. We were very proud of these results. Like I said earlier, proved that our design actually was worth something. So, looking back on our design, we had a lot of opinions and stuff we would have liked to do differently. Ultimately, we were proud of how our design went, but obviously we're never satisfied and we wish we could have done more. For one, even though it was thin enough, we wish it could have been a little thinner, mainly to reduce any distractions from either passengers and such trying to look, and maybe like this thing would be in their way if they're trying to look at something. We really wanted to get rid of that maybe. And we would also like to find a way to add an adjustable system where you can move the actual piece of tint up and down to cover a different area should you need it. And I think if we had more time and we had more time and commitment, we could have probably fleshed out this design a little better into something we'd be more proud of. All right, that's everything.
So did you guys make just one prototype and do your testing on one item?
We did make one of these.
Okay. Did you think about any other alternatives?
We did think about some different alternatives, like maybe building something into the actual front windshield itself and not a standalone unit. But we found, although it was possible and we really liked the idea, we didn't have the time or experience in the beginning to do that.
When you reviewed current past solutions that are out there now, how many of those did you review? Did you look at?
We had 2 patents each, so 6 in all, but we only chose 3 on each.
Okay.
The other 3 were sort of tailored to our other designs that we were thinking about choosing, but we figured we should only show the ones that were relevant to our final solution.
Right. How about the most frustrating part of the entire process?
So I can talk about that.
Or maybe it's different for all 3, I don't know.
Well, we definitely all had our own moments, but mainly as a group, we had around like a week and a half span where we had nothing but trouble with the 3D printers. Some of it was they were having issues on their own without us interfering, but other times it was sometimes our designs were set up incorrectly. So for like a week and a half, our schedule for the day would be we would come in, evaluate our 3D print from the other day, see if we liked what happened. More often than not, we would have ran into some sort of issue that we didn't like. So we would do a redesign, small tweaks here and there, and then reprint it. This went on for about a week or so before, one, we realized some of the printers were actually having issues themselves, and two, some of our designs, either going from the software we use, it's called Dremel, to the 3D printers itself, something along there was getting messed up. But thanks to the help of Mr. Dunn, we were finally able to get it fixed.
Anything else on that?
You go.
The most frustrating part for me was in the beginning. We had a different solution we were making, and we presented about it, and we kind of got like shut down because it just kind of already existed. So we had to go back to the drawing board and kind of figure out everything.
I think another frustrating process was deciding which product to use, because we were in the class day after day writing on the whiteboard on the pros and cons of each and describing. So we had a few arguments, but we eventually explained it to each other and we got through it. Which was our final design.
That's good, because that's exactly how life is. That's how the world is. So you gotta get through those obstacles. Very good.
I think it definitely helped us as a group, going through our different designs and actually talking it out, not being afraid to like hide any of our opinions. I think we definitely succeeded a lot better, like not being afraid to like say like some of the stuff that we didn't want to hear. Like we had to tell each other like some of this is on like it's not feasible, we can't do it. And other times it's just like other stuff we thought was like it's just not good. So but like having those tough conversations really helped us in the long run. We were able to work together better because of what we went through.
Did you actually drive the car with this?
No, we didn't. Unfortunately, we couldn't do that. We had limited ability when we were testing it because we had some more flaws with the 3D prints. It's a common theme with our project.
Okay.
But we were able to test the installation and the placement, which we really liked. But not assuming, because we know the clip would work, it should be very easy to drive because it covers your main field of vision when you're looking around. And we also did some testing from looking there and then ours to see if there's like that effect when you look from somewhere darkness to bright. We really didn't find that because although it was being tinted a good amount, it wasn't enough to cause that.
All right.
I was just curious how you decided how much tint to buy, like the plastic that you bought. How do you decide how dark you wanted that to be?
So we looked at Amazon. We actually looked on a multitude of websites, but we finally decided on Amazon, and we found a lot of pieces of tint on there. Well, we didn't really know exactly how dark it would be, but when we got it, we got lucky and we saw that it was good enough. But
We weren't sure how bright we wanted it to be, but we were gonna look at purchasing a few different samples. But when the first one came in, we examined it. We found out we actually really liked it and that it worked for our intended goals, so we decided to stick with it.
Why did you decide to go with the cylinder as opposed to other hazardous conditions?
Some of it was a few of our other ideas were tailored to winter markets, which it's a very niche market. It's hard to work on a project that would only benefit like a certain amount of people, especially in only like certain seasons, certain months. So it's hard to design a project and then also test it that tailors to certain people in certain months. So we figured one of the problems year round that people experience is brightness and sun glare. So if we can tackle that problem, we have a better design.
any other questions?
All right, thank you.
Yes.